Hello folks, and this video is going to be all about the function of bones and classification of bones. So the first question that we're going to be asking, if we're thinking of bones in general, is what is bone? A lot of folks may just be thinking that because bones are very hard that they're not alive. But as we know from learning about the osseous tissue, that bone is alive, right? Not only is it alive, it's dynamic. So what does dynamic mean? It means that it has the ability to repair itself and remodel itself, and there's movement within the bone. There's blood flowing through it. There's nerves within the bone as well. And that tissue is going to be, again, living and dynamic. And also, bone has the ability to respond to its environment. So that means because it can repair itself and, of course, remodel itself, the cells within our bone tissue, like our good old osteocytes and our osteoclasts, are able to respond to different changes in homeostasis. So, for example, with our osteoclasts, we know that if we are low on calcium, that it can begin to break down the extracellular matrix that has those calcium minerals involved in them to be able to produce calcium for the body. Or if you have wear and tear and a lot of mechanical load, then we know that our osteocytes can help with minor repairs and, of course, adding bone to make sure that we actually are getting those tiny repairs happen. If you need more bone, then you know those osteoblasts are going to help produce that bone tissue. Now, the next thing we know about the skeletal system, which is what we talked about as well, is that the skeletal system has 206 bones. We're not going to focus on all 206. That's chapter 7 stuff. Okay, it has 206 bones, and there's also associated cartilage. And understanding the bones and the cartilage just makes it very easy to be able to identify the types of bone and how bone is built, and also what bones do. So that's really the whole goal here, is figuring out what they are, the types they are, how are they built, what do they do. That's the whole goal of the next piece of this chapter. All right, and one thing to add here is that even though we're saying the skeletal system is made of 206 bones, it does vary between persons. So a lot of times when we're looking at a textbook and everything that we're learning, we always try to go off of the most general version of these organ systems to make it easier for understanding. But remember, things can change from person to person. Also, when we're talking about living, we're talking about the the fact that there is blood flowing through the central canal of these bone tissue or osseous tissue as well. And because of their structure and how bones are made, then guess what? That's going to help inform the different major functions of bone. So there's usually different 7 functions of bone that we see in our text. Some texts can have lower than that because it's all about how you're going to be gathering information. I show 5 here, and remember, the reason why is because I'm going to basically put a couple of the functions together. So let's first talk about support of the body. So we know we're talking about we have hard bones, and we already said they're very rigid and hard due to the extracellular matrix. And that's really great because our skeletal system is going to give a shape. So we look at this guy here and we see that all the hard bones in the body is going to give the body its shape. And of course, it's going to be able to uphold our shape as well. Think about it. If you have bones like your ribs, what do they house inside of them? Or your thoracic cage, what does it house inside of it? It houses your lung. And so the interesting part is when it comes to the actual ribs, that actually helps the lungs function. When you breathe, you need the ribs to be able to expand so that when the lungs are filling up with air, they have the ability to move and expand as well. And so that's where we're talking about support as well. Okay. Then we know that the function of bones is to protect. And what they're protecting? Soft tissue organs. So one of the examples would be our skull protecting our brain. Now, some folks will be like, let's get an example. Well, unfortunately, what if you fall? What if you fall? If you fall and bust your head on the ground, your brain's not automatically going to just spill over because your skull is there to help protect the brain. Now, of course, you're going to get a lot of impact there. But the goal is that we should be able to absorb some of that shock from the actual skull itself. Now, of course, depending on the force that you go down, what you're specifically hitting, you can crack the skull, et cetera, et cetera. But just understand that's one way we can get protection. Also, our rib cage as well is going to protect our lungs and also protect our heart. So it's all about being able to protect those soft organs within. The next function of bone is going to be to produce blood cells. So yes, we have our red bone marrow that helps produce blood cells. Another thing it produces is also hormone We don't focus too much on the osteocalcin. So let me write that down. Osteocalcin of the endocrine system. That's going to be helping us basically produce hormones, and this is going to help regulate insulin secretion, for example. Okay, so that's me just basically taking two functions and making them into one. Another major function is to store fat, triglycerides, and minerals. What minerals? Well, we already know one of the main ones we talk about is good old calcium. And if we need calcium in the body, then we know that our osteoclast is going to help us get it. Okay, so calcium in the matrix, and of course, fat storage. That means it's storing energy within that medullary cavity, which we're going to talk about later when it comes to long bones. And finally, the last function that we're going to focus on is the fact that bones act as levers for muscles. And so we have to think of the fact that, okay, well, bones work with muscles, okay? And muscles, right over here, pull on bones. That's what they do. Muscles pull on bones. And say your muscles pull on your bones for me with my arm, then of course my arm will bend. And you see a person here that is going to be using this lift to help with, well, they're going to be using this lever to help lift this particular amount of weight. And that's going to be the interesting thing when it comes to bones acting as a lever. And as we get into chapters 9 and 10, when we get more focus on the muscles, we'll be able to talk about the types of muscles and how they act as levers as well. Now let's go ahead and get into the classification of bones. Another way to say classification of bones is just say the types of bones, okay? So what this means is, if you're given a pile of bones and you had to categorize them, how would you categorize them? You'll categorize them based on their shapes, what they look like. And as you go higher, they say, okay, this is some pile of bones that's specifically from the thoracic cavity. Then you say, okay, I'm going to categorize it by its shape and its location. So let's go ahead and get into our first bone, which is going to be the long bones. And the long bones are like always the easiest one to remember, because I feel like people will just say, okay, here's a bone that I know, and let me just grab it. Or if you're thinking of when you're a kid and you're thinking of skeletal system, you always can see the long bones easier. And a long bone will be like our humerus here. And it has some specific characteristics. So first things first, it's shaped like a rod. So you're looking for bones in that pile that are shaped like a rod. And that rod has a shaft and expanded wider ends. So as you can see here, this will be our shaft of the humerus, and we have wider ends. And that would be an example of a long bone. So for us, it'll be our arm and our leg bones, but also it can be our finger and our toe bones. Don't forget it's fingers and toe bones as well. And some folks will be like, fingers and toe bones, they're very, very small. Shouldn't they be short bones? Well, no. Even though they are short, they still have a shaft with wider ends. And that's going to be the shape or characteristic that we're looking for when we're talking about long bones. Next, let's get into those short bones. So some short bones will be like our wrist bones and our ankle bones, or our carpals and our tarsals. And when you're looking at them, you'll see that they are basically sort of cube shaped, but a lot of times you'll see them as small little lumps. And even some folks call them like little spheres. And they're very hard to identify, especially if you have a pile of bones in front of you. You're like, all these little tiny short bones are going to be harder to identify. If we're looking at the wrist here, we see a lot of these little short bones. As you can see, they're not long bones because they don't have a shaft with wider ends. They're just short, kind of cube-shaped bones. And so again, they're harder to identify, but I feel like once you get used to it, you pick it up, you're able to see it in 3D motion. It makes it easier for you to be able to start to identify them better. Next, let's get into flat bones. So what is the characteristic for a flat bone? Number one, they're thin, they're flat, and they're slightly curved. The example we see here is the sternum. And if you were to hold the sternum, you'll see it's a very thin and flat, but it also has a slight curve to it. Another thing will be thin and flat will be the ribs. And some folks might say, well, ribs are very long. Okay, but do they have widened ends? They might have a longer shaft, but do they have those widened ends? No, they do not. And also, they're very just thin and they're very thin overall. So if you're thinking of a long bone, they won't have that thinness, and it'll actually have a long shaft with wider ends. Remember that. Whereas a flat bone will be thin. No matter how long they are, they will be very thin. That's going to be something that's there. And also slightly curved. Okay. You also have cranial bones, which are basically going to be curved plates of the skull. And you'll see those are very thin as well. Okay. What else can we think of here? Oh, our scapula. Right down. Our scapula. Okay. You can also say the shoulder bone. So I've kind of drawn a little piece here. And when you actually have it in your hand, you'll be like, wait a minute, this looks kind of different because it does have those bony extensions or projections coming out of it. But you want to ask yourself, is this thin? Is it flat? The answer is yes. All these pieces here will be thin and flat. And then for the projections that are coming out of it, you also want to ask the same question. Is it thin? Is it flat? And the answer will be yes. These bony projections will also be thin and flat as well. So therefore, that bone will be a flat bone. So the scapula is a flat bone. The type we're going to get into is irregular bones, and they're named because they have irregular shapes. Now, the hard part is going to be distinguishing flat bones from irregular bones, because you're like, wait a minute, flat bones look strange as well. They don't have these like perfect shapes. And so they both have odd shapes in some kind of way, but you have to ask yourself, is it an odd shape that's thin, meaning it's a flat bone, or is it an odd shape that has some thick parts, and that will be considered an irregular bone? So an irregular bone can have thin parts, but it also can have a lot of thicker parts as well. So think of your facial bones, your pelvis, think of your spine or your vertebrae. Those are all going to have different types of shapes. And here we see our vertebrae. So you see it's irregular. It has shapes, but there's also going to be some thicker sides to this as well. It's not completely thin, and all the projections are not thin as well. And that does make the irregular bones a little bit harder to describe because they're so different. But just understand right now, if you're just doing categorization and classifying irregular bones, yes, they can have odd shapes, but they do have thicker parts in some areas. They're not thin and flat and slightly curved only. Okay, so that'll be one way to distinguish flat bones and irregular. Another thing you can look at is like your sacrum vertebrae, which again is going to be irregularly shaped, and it has thicker areas as well. And so again, when you're in lab and you're looking at these bones, you want to make sure you start classifying them first. That'll be the first way on any kind of exam to classify them. Finally, let's get into our last type, which is going to be sesamoid bones. Now, I did tell you that sesamoid bones are usually classified as short bones in some textbooks, and I believe for ours we do have sesamoid bones separate. Okay, so just keep in mind. And the reason why is because they're small. They're small, just like short bones, and they have weird shapes. A lot of times you'll see them look like a sesame seed, and that's the reason why you see sesamoid bone. But the difference between a short bone and a sesamoid bone is that sesamoid bones are going to develop inside of a tendon. Okay? And that means the first thing to think of is your patella. So your patella, which is going to be for a part of your knee here, your patella, is going to be growing inside of the patellar tendon. It grows inside patellar tendon. So you might be like, okay, I see a short bone, but does it grow inside a tendon? If the answer is no, then it's a regular short bone. If the answer is yes, it's a sesamoid bone. Well, the cool thing here is that these bones are going to vary in number. So remember I was telling you there's 206 bones. That's great, but not everyone has the same number of bones, person to person. That's because some of these sesamoid bones are going to be, some people may have them, some people may not. So just keep that in mind. And one example, again, is going to be our patella. Now, if you were to just take this patella out in like a disarticulated skeleton, like or that pile of bones that I talked about, you'll see it's very small, but you have to start having more details like, okay, this is very small. Do I think that it grows inside of a tendon or not? Go ahead and get into another visual of the classification of bones straight from our textbook. And that's what we have here. So we definitely have that long bone. Remember, we need a shaft, long shaft, and we also need widened ends. So if you're holding a bone in your hand and it has a longer shaft with wide ends, that is a long bone. No matter if it's coming from your actual toes or your fingers, those are long bones. Okay? And we'll get more details about long bones as well, because again, they hold all of our bone marrow, especially our yellow bone marrow, which is going to be storing fat. We'll talk about how this shaft is actually a cavity. So we'll get those details next. Also, you can have regular bones as well, and this is going to be a better visual of the actual vertebrae. You see how regularly shaped that is? You might be like, well, this is definitely a flat bone. See that shape? Well, guess what? It'll be depending on what you have in your hand. You want to ask yourself, is it going to be thin and curved and flat? Or does it have thicker pieces to it when it comes to those projections? If it has those thicker pieces, it definitely isn't a regular bone. Next, we have an actual flat bone, which is going to be the sternum. So yes, we see this like little regular shape here. It's a regular shape. And of course, the next question is what? Is this odd shape going to be thin, flat, and curved? Yes, if you have the sternum in your hand, you want to, of course, move it around in a 360 manner. Feel how thin it is across the entire piece. Is it curved slightly? Sometimes these flat bones may be curved slightly, and it could be very, very slight to see, but you definitely want to make sure that they are thin as well, okay? And then, of course, we talk about the short bone. So this is going to be a little bone, a little short bone that's a part of our tarsals, folks. And look at that little bone. You might be like, wait a minute, is this an irregular bone? Because when I grab on it and touch it and everything like that, I definitely see an odd shape. But you want to make sure that, again, if you're looking at the overall shape of it, is it a tiny shape or is it like a larger shape that looks irregular? This is a very tiny shape. Another thing you might ask yourself is this a sesamoid bone? Then you have to ask yourself, is there tendons around and is this bone going to be, growing in that tendon? The answer will be no for the tarsals. And of course, we have the sesamoid bone here. And what is our main question here? Yes, they're going to be short, but does it grow in a tendon? And the answer is going to be yes, because that patella, it grows inside of the patellar tendon. So that's how you can start classifying your brain around what these different classifications of bone are. And remember, I just want to write thin and flat, slight curve here. And then I will have thick areas, odd shape, not small. So you want to make sure that you are able to take irregular bones and not confuse them with flat bones or short bones. Okay, folks? Hopefully this video helps. Let's go ahead and get into some gross anatomy of bone structure.